So hello guys, welcome back to my channel again, and today we'll be talking about other measures of variability and spread. So that is range and interquartile range, and I will also talk about the outlier and Whisker plot and box plot. Okay. So in last video we have stopped here. So if you have any doubt in this question, then please ask using the comment, and I will reply. Okay. So let me start with the other variability of and spread measures. Okay. So what is range basically? So range is very simple but very impactful measure in the statistics. So what range tells you, like it is nothing but the difference between the maximum value and the minimum value. So that is the difference, and that is known as range. Okay. So we'll also talk about like what is the significance. So for example, suppose you have these numbers. So these are the numbers available in your data set in one particular column. Then what is the range for that? Okay. So for that, what you do, we just identify the minimum value, and then also you identify the maximum value, and then you take the difference, and that becomes your range. Okay. So range basically tells, okay, in what range your data values are varying, and that's why this is also a measure of variability. Okay. And let me also understand with the help of one like a graphical representation. So suppose there is a min value and there is a max value. Okay. So if you take the difference, that is max minus min, then this line denotes, so like from max till min. Okay. So this line denotes the range. So this whole range. Okay. And then what are these 2 points basically? So these 2 points denote the Q1 and Q3. So what is Q1 and Q3? The Q1 denotes the lower quartile and Q3 denotes the upper quartile. Okay. In a moment, we are also going to solve one example to understand in more detail like what is quartiles. Okay. So quartiles tells you like the spread the percentage spread of your data values. So for example, what Q1 tells? Q1 tells like the bottom 25% of your data lies in this range. Okay. So when we talk about this range, then Q1 becomes the max value for this. Okay. And mean value is anyway the same. So bottom 25% of the data is denoted by Q1. Okay. And then middle 25% of the data is denoted in between the range of Q1 and Q3. This point, this range denotes the middle 50% of the data. And then if you sum 50 and 25, this from mean point till Q3. So Q3, that is the upper quartile or Q3 value that denotes the bottom 75% of the data starting from this mean point. Okay. So bottom 75% of the data is denoted by Q3. And then remaining top 25% of the data is denoted by this range, that is Q3 to max. Okay. And from these data points, there is something called IQR, that is interquartile range, and that is denoted by the mid 50% of the data. Okay. So that is IQR. So the difference between the largest and smallest observation in the sample is the range. Okay. Now why this is important, guys? Let's understand. So suppose you have see, when we do the data analysis, okay, then generally we ask our data engineers to collect some data, and then for that they write some data pipeline or whatever the manner they collect the data. Okay. And in some automated manner or some manual intervention also involved. Okay. And then we have an age column, and there we have written a value like 145. Okay. And a person having age of 145 is very rare, right? Very, very rare or almost impossible, right? I don't know in history anybody has reached the age of 145. Okay. But it's very rare. So that's why, like, if you see those kind of values in your data set, and then if you have a range available, so suppose your range says, okay, in between 1 to, or I mean, first day 1 to like 100 years, okay, from 1 year to 100 years. So that is range, or 1 to 110 year. You define, okay, 1 to 110 years, that is range. And then you get suddenly a data value as 145. Then immediately you understand, okay, this is a wrong value, right? So maybe anomaly. So that anomaly kind of identification or wrong data value identification, that time range helps you. Okay. So then it will indicate, at least it will give you some clue. Okay. We have done some mistake in data collection. Then either we go back and collect the correct data, or we take some other measures. Like for example, we want to replace that value with the correct value, right? So there are some methods. So that's where the range helps you. So range can be helpful if we are measuring a variable which either has a critically high or a critically low value that should not be crossed. So the range will instantly inform you whether any crossed the critical threshold, or whether any value has crossed the critical threshold. Hence, it can be very useful to detect errors while entering the data, right? So suppose while recording the age of a school students, your range is 7 to 123 year, and then you will immediately know that you made a mistake if your any data point crosses 123, right? So that's where this range helps you. Now let's understand the quartile in more detail, that is Q1 and Q3. Okay, and then we have a Q2 also, that is in between. Okay, so Q2 will be like the median, the central point. It will come here somewhere. Okay, and that tells you the bottom 50% of your data. Okay, so we'll talk about that. So let's understand what are the quartile and what are the interquartile range in more detail. So quartiles are nothing but it breaks the data set into quartiles. That is the 4 equal points. Okay. So suppose let's understand this concept also with the help of one example. So suppose we have employee salaries and they are written like 70K, 65K, 55K, and likewise. Okay, and some salaries are coming twice, like 85K is two persons having 85K salaries. Okay, and we have data of around like 3 to 5 to 7, 8, 9, 11 employees data we have collected. Okay, so for concept understanding, this is enough. So what we do, like how to calculate the quartile, we arrange the data in ascending order, and we also calculate like how many data points are there. So total data points are n is equal to 11. Okay. And then we calculate the lower quartile. So what is lower quartile basically? So lower quartile, that is denoted by Q1, it tells you the bottom 25% of it. So quartile means 4 equal parts, right? So if we understand like we divide the whole thing in the 100 percentage, then 25 percentage, 25 percentage, 25 percentage. There will be 4 blocks. Okay. So that are denoted by quartile. So the first quartile Q1 is denoted by bottom 25% of the data. Okay. And how you calculate basically the formula is like n plus 1 by 4. N is your total number of data points and you add 1 and then divide by 4 means 4 quarters. And then you take the ceiling value. Okay. So here 11 plus 1, that is 12 by 4, it comes 3. Okay. Third value. And if it has come like 3.6, then you take the fourth value. Okay. Ceiling value. Okay. And guys, here this formula will remain same either n is equal to even or odd. Okay, because in median calculation we have seen if n is even, then formula is different. If n is odd, then formula is different. Okay, so here formula is same because we have like ceiling function. Okay, then third value, and third value from the beginning because we have already arranged the data in ascending order. So third value, what is that? 1, 2, 3. So 47 will be your first quartile. So what does this mean? So bottom 25% of the salaries of the employee will be less than 47K. Okay. And then middle quartile, that is median, that is 50 percentile, Q2. It will be nothing but 2 into n plus 1 by 4 and then ceiling. Okay, apply ceiling function. Then that will be the sixth value from the starting, that is 70. So here you see, okay, don't count the frequency 1, 2, 3, 4, 5, 6. 6 is not 78. 85 and 89 comes twice, right? So that's where you write individual data item 1, 2, 3, 4, 5, 6, right? 70K. So 70K will be your Q2, that is a central value. So it means like your bottom 50% of the data is less than 70K. And then upper quartile, that is 75th percentile, is nothing but the 3 into n plus 1 by 4 and upper like ceiling function, and then you calculate that is the ninth value from starting. That is nothing but 85K. Okay. So your 75% of the salaries are less than 85K. Okay. So in overall organization, 75% of the employees are getting less than 85K. So that's what its significance is. And then how to calculate the interquartile range. The interquartile range is nothing but the difference of the upper quartile minus lower quartile. Okay, that is the middle 50% of the data. So 85K minus 47K, so that is 38K. So what does this mean? So middle 50% of the data is scattered around 38K. Okay, so central, if you just talk about the central like 50, 65, 70, 78, 85, like that, okay, here. So middle 55% data average salary is like around 38K. So they will be scattered around 38K. That's what it means. Okay. And now we understood what is Q1, what is Q2, what is Q3. That is the quartile. And we also understood what is the interquartile range, IQR. But what is the significance? So we have understood the significance of Q1, Q2, Q3. That is the bottom 25%, middle 50%, bottom 25%, bottom 50%, then bottom 75%. Okay. That is denoted by Q1, Q2, and Q3. And then we didn't understand the IQR significance. Okay, of course, we understood the middle 50% of the data, but that is not much intuitive, right? So let's understand this in more detail because that is very important. So we'll understand this with one more example, and with there we also understand what is the box plot and what is whiskers. Okay. So let's we have, suppose there are four columns, four different series 1, 2, 3, okay, and 4, and we have different data points available with respect to each column or each series, okay, and we have plotted the scatter plot. I have plotted this with the help of Excel sheet. So what you can do, you can select this whole data in your Excel, and you go to the chart, and then you can select the like box plot, okay, and then you will get the same chart. Okay, but in next video, I'm also going to take a Python exercise live class, okay, where I am whatever concept till now I have covered. So for everything, I will be executing one Python notebook. Okay. So let's understand what this all about. What is box plot? Basically, the box plot or whisker plot in general helps you to identify the outliers in your data set. Outliers means extreme values. Okay. So let's understand this also. So I'm just focusing on this series 4 and this last box plot, okay? And then the concept will be same for all these three as well, okay? So now box plot helps you to identify the outliers or extreme value. But the question is like how? Okay, so let's see. So where Q1 will be represented in box plot, that is the Q1 is the lower quartile, and that will be represented by 60 here. Okay, the like, so if you just focus on this rectangle, okay, this rectangle, so the bottom value of the rectangle is 60, and that is lower quartile. That is the lower 25% of the data. Okay, and then Q2, that will be in the center of this rectangle, this middle rectangle. Okay, that is 70. Okay. So I'm talking about this data point, this series 4, okay? And if you calculate, like in previous slide, I have shown how to calculate the Q1, Q2, Q3. Then if you put the formula, then you will get exactly 70, okay? And then Q3 is upper quartile. So in box plot, this center rectangle represents your Q1, Q2, and Q3 values, okay? And then now let's talk about what is this 4, 55, and 150, and 105, okay? So now 105 is denoted as upper whisker, and that's where the help of IQR comes. IQR is like this point. So this 85 and 60. So this range is your IQR. That is Q3 85 minus 60 Q1. So that is your IQR. Okay. And then upper whisker. Okay, that is upper range, extreme value range. Okay, what this means, I will tell you. So first, let me explain how to calculate this 105 and then what is the significance of this 105 value. Okay. So this is nothing but upper whisker is calculated by Q3 plus 1.5 times IQR. Okay. So we have stretched the range, that the central range, central 50% of the data values, the central IQR with 1.5 times, we come little up, and then we added Q3 value on that one. Okay. So then we came somewhere here. Okay. So if you will calculate Q3 plus 1.5 times IQR, so what it will come? So let me calculate quickly. Okay. So let me take the pen. Okay. So if you calculate, okay. So upper whisker. What? So it will be like, what is Q3 plus 1.5 times IQR. Okay. So what is Q3 value? That is 85 plus 1.5 times IQR. What is IQR? IQR is Q3 minus Q1. So 85 minus 60. Correct? What it will come? 85 plus 1.5 times. What is this? 25. Okay. And let me quickly calculate this. Okay. So if you will calculate this, then it will come like 122.5. You can calculate this as, okay. So now what does this mean? It's not always necessary whatever value you get after this calculation that is available in your data points. Okay. So 122.5 is not available in this series 4. Okay. So that's where upper whisker is like less than or equal to the closest value that is less than or equal to this calculated value. And if you find what is the closest value, just less than to 122.5, so that is 105. So that's where upper whisker will become 105. Okay. So that is upper whisker. But if you are asked to find out the outlier, so we have a range here. Okay. So this range. So this somewhere here 122.5 will come. Okay. Any point beyond this here, okay, any point beyond this, that will be your outlier. We still have this buffer available. So from 105 till 122.5, any point is coming, your whisker value will increase and max range is 122.5. Your upper whisker can go up to 122.5. Okay, and then any point beyond this 122.5 will be your outlier. So that's where this box plot helps you to detect the outlier. Okay, this is the upper side scenario. Now let's focus on the below side. Okay, so this 55, this is the lower whisker. How you calculate? Q1 minus 1.5 times IQR. Okay, so let's calculate. What is Q1? Q1 is like 60 minus 1.5 times IQR. IQR we have calculated, that is 25, right? Here we have calculated this 25. So what it will come? Let me calculate quickly. Okay, 22.5. Now any value greater than this, because this also not the case it is available in your data. If it is available in your data set, that will become your whisker point. Okay, but if it is not available, what is the closest point just greater than this? Okay, so 22.5. So closest point will be 55. So this will become your lower whisker. That is here. Okay. And but we have, because we are going towards this direction, so this direction value will decrease. So we have a buffer available till here. This point is like 22.5. 22.5. So till here, so this will be the max value for the whisker, right? Till here. So here it is 55, it could be 50, then 47, then 45 till 22.5, right? But any point beyond this side, bottom side, that will be your outlier. Okay, your whisker can go up to 22.5. Okay, and that is the max range for lower whisker. But we don't have any points. The nearest point is 55, so that becomes your available whisker in your data point, right? But max whisker can go till here, and beyond that, that will be your outlier. Any data point beyond this will become your outlier. Suppose 47 is available in your data set, then your lower whisker will be 47 here somewhere, right? So that's not your outlier. Outlier will be beyond 22.5. Okay, so that's a very good objective question. So this is, yeah. So that's how box plot helps you to identify the outliers. And these are the whisker. This is upper whisker and this is lower whisker, 55 and 115. Okay. So this is about box plot and whisker plot, guys. And then, of course, beyond that, 150 is your upper, 150 is like upper side outlier, and then 4 is like below outlier. So in this series 4, we have two outliers, 150 and 4. And similarly, similar concept like in series 3, we have 250 as outlier. We don't have any lower outlier. And in series 2, we don't have any upper outlier. We have 10 as a lower outlier, okay, lower extreme value. And in series 1, there is no outlier. There is no extreme data point, right? So that's how you detect the outliers, guys, with the help of IQR or box plot. So there is one more very good method to detect the outlier, that is using Z-score. That I'm going to talk in next video. Okay. Otherwise, there will be too much in this video. So guys, any same thing, whatever I explained, I've written for your later reference point. Any point which is greater than Q3 plus 1.5 times IQR or less than Q1 minus 1.5 times IQR is known as outlier. Okay, guys. So this is about your like range IQR, Q1, Q3 quartile values and how to calculate the quartile, and then how to understand like what is the significance of box plot and whisker plot. Okay, guys. The next video I'm going to talk about the Z-score, and we'll also understand the outlier identification with the help of Z-score. Okay, so stay tuned. And if you like whatever I explained, then please don't forget to subscribe my channel and also share with your colleagues. So thank you.